Assalamualaikum warahmatullahi wabarakatuh. My name is Syaratu Usman binti Ahmad Tamizi with a metric number 1171471. My group will present about X-ray diffractometry, which is SRD. So I am the first presenter. The second presenter is Nur Nabila binti Maidin. The third presenter is Atia Sakina, and the last presenter is Nur Ifa'in. So for my part, I will cover about basic theory and principle of X-ray diffractometry. Okay, first thing first, let us see about the basic theory. Okay, the basic theory is about single and double slit experiment, which is in this experiment, visible light was used to produce a diffraction pattern on the screen, which is this experiment are possible because the weight of slit was on the order of the wavelength of visible light. If the weight is much larger than wavelength of wave, diffraction will not be observable. So, in 1923, Wilhelm Röntgen have found about X-ray, which is X-ray is an electromagnetic wave that have a wavelength about 10 to the power of negative 10 meter. Thus, in 1912, Max von Laue suggested that a crystalline pair of atoms might have a spacing small enough to create a diffraction pattern using X-ray. And the distance between crystal atoms about 10 to the power of negative 10, and the separation distance is on the order of the wavelength of the X-ray. So this is the basic theory of the SRD. Next, move on to the principle of SRD. So, in crystalline atoms are arranged as shown like this, and the separation distance is on the order of the wavelength of the X-ray. The two incident X-ray to one another make an angle with respect to the plane atoms. When X-ray A and B reflect, they will interfere constructively when they travel a total distance that differs by the whole number multiple of their wavelength, which is when two waves are fully in phase. Okay, next. So, when the wavelength is known, the angle and the distance between atoms can be found. Okay, so this is the basic of the X-ray diffraction, which is also called as the crystallography. Next, for the addition information, X-ray diffractometry or SRD, also known as the X-ray powder diffraction, which is an X-ray based method for determining the crystal structure of a material. This SRD can be done by irradiating a sample of material with incident X-ray and then measuring the intensities and scattering angles of the X-rays that are scattered by the materials. So next, I would like to share one of the videos about the basic SRD. Enjoy. Thank you.
What is X-ray diffraction, and what is it used for? In an X-ray diffraction experiment, a sample is placed into the center of an instrument and illuminated with a beam of X-rays. The X-ray tube and detector move in a synchronized motion. The signal coming from the sample is recorded and graphed, where peaks are observed related to the atomic structure of the sample. Most materials are made up of many small crystals, like sand on a beach. Each of these crystals is composed of a regular arrangement of atoms, and each atom is composed of a nucleus surrounded by a cloud of electrons. It's at this scale that the story of X-ray diffraction begins. X-rays are high-energy light with a repeating period called the wavelength. Since the wavelength of an X-ray is similar to the distance between atoms in a crystal, a special interference effect called diffraction can be used to measure the distance between the atoms. Interference occurs when X-rays interact with each other. If the waves are in alignment, the signal is amplified. This is called constructive interference. If the waves are out of alignment, the signal is destroyed. This is called destructive interference. When an X-ray encounters an atom, its energy is absorbed by the electrons. Electrons occupy special energy states around an atom. Since this is not enough energy for the electron to be released, the energy must be re-emitted in the form of a new X-ray with the same energy as the original. This process is called elastic scattering. In a crystal, the repeating arrangement of atoms form distinct planes separated by well-defined distances. When the atomic planes are exposed to an X-ray beam, X-rays are scattered by the regularly spaced atoms. Strong amplification of the emitted signal occurs at very specific angles, where the scattered waves constructively interfere. This effect is called diffraction. The angle between the incident and the scattered beam is called 2 theta. In order for constructive interference to occur, the scattered waves must be in alignment, meaning that the second wave must travel a whole number of wavelengths. In this case, 1/2 of a wavelength is traveled on the incident side, and 1/2 on the scattered side, yielding 1 additional wavelength. In the case of the next X-ray, 1 wavelength is traveled on both the incident and the scattered side, resulting in 2 wavelengths. This reinforcement occurs throughout the crystal. The exact angle at which diffraction occurs can be determined from the red triangle. The angle at the top is theta, half the angle between the incident and scattered beams. The long side is the distance between the atomic planes, and the short side we know is 1/2 of a wavelength. The relationship between the diffraction angle and the spacing between the atoms can be determined by applying the sine function. Rearranging this equation yields an equation commonly known as Bragg's law, named after Sir William Henry and William Lawrence Bragg, a father-son team who won the Nobel Prize in 1915 for their work analyzing crystal structures with X-ray diffraction. This technique of X-ray diffraction is used today for a wide variety of materials, ranging from single crystal epitaxial thin films to polycrystalline mixtures of powders and even randomly oriented amorphous materials. X-ray diffraction helps scientists to develop new pharmaceuticals, classify rock formations based on their mineral components, and understand how the arrangement of atoms affects the behavior of energy storage materials. As scientists push their ability to engineer materials on the atomic level, X-ray diffraction becomes an increasingly important tool in their toolbox. Advances in equipment design have made X-ray diffraction easier to use and more powerful than ever.
For XRD mechanism, the main component for XRD machine are first X-ray tube, then the second one is a sample holder, and the third one is X-ray detector. XRD machine works first by X-ray are generated in a category tube by heating a filament to produce electron. The electron then accelerating toward the target by applying a voltage, then it will bombard the target materials with electron. When electron has sufficient energy to dislocate the initial electron of the target material, characterize X-ray spectra or borders. The X-ray produced are collimated and directed into the sample. As the sample and the detector rotate, the intensity of the reflected X-ray will be recorded and the data.
Application of X-ray diffractometer, or known as XRD. There are some applications of XRD. Firstly, XRD can use for measurement of sample purity. For example, it can evaluate DNA purity. Did you know good quality DNA will have absorbance A260 A280 and ratio of 1.7 until 2.0. It usually used in forensic area. XRD is also used in agriculture area. In agriculture area, XRD is used to analyze soil for planting. Secondly, the characterization of crystalline material. It is one in which the atoms are situated in a repeating or periodic array over large atomic distance. Some of the properties of crystalline solids depend on crystal structure of the material. The example of crystalline material is metal, polymer, and ceramic. Thirdly, determination of unit cell dimension. The unit cell of a mineral is the smallest divisible unit of a mineral that possesses the symmetry and properties of the mineral. Lastly, identification of fine-grained minerals. Mineral grain is too small to be seen with the unaided eye. The example of mineral is rhyolite and basalt. It used to manufacture stone tools, particularly scrapers, blades, and projectile point. Relevant issue that related with XRD X-ray diffractometer is temperature. Certain crystalline structures have their own temperature. When there are difference between their temperature and the supplied temperature, the result will be deflected.
Now we move to the related topic to the X-ray diffractometry, which is photoelectric effect. Photoelectric effect is a quantum electronic phenomenon in which electrons are emitted from the matter after the absorption of the energy from the electromagnetic radiation. The emitted electrons are called the photoelectrons. Photoelectron begin emission of the electron when the electromagnetic radiation like light will shine on the material. Electron the emitted will call the photoelectron. X-ray will have several characteristics of the wavelength X-rays. Last but not least, we move to the Quran verse, which is nakli and akli, that's suitable with our topic X-ray diffractometry. We can take a look at the verse 24-35, which is Surah An-Nur. Here the Surah An-Nur verse 35. This ayat tells us about Allah give us a light that we have many beneficial to all humankind in the universe. Light that comes from the sunlight can make our earth become more lighter. Al-Quran is the light of the heaven and earth, that He illumined both of them with a sun and moon.
That's all from us. Thank you.